Hey there, math hoppers! In this video lesson, we will learn how to determine coterminal and reference angles. First, let's go over some basics. When we have angles, remember we have an initial side, that's where we start the measurement from. We have a terminal side, that's where the angle ends. We, of course, have an angle measure, and remember that we use Greek symbols to represent angle measures. Whereas we used letters for the variables for side measurements, we generally use Greek symbols like this theta for angle measurements. Remember, of course, that angle measurement describes both the amount of the rotation and the direction of the rotation. And that means we can have positive and negative angles. We have 120 degrees here, or 2 pi over 3 radians. So we go from the initial side and we rotate counterclockwise, the direction we're kind of used to going in, and we stop here at 120 degrees, or 2 pi over 3. So positive angles rotate counterclockwise. On the flip side of that, we have a negative 210 degree here, or negative 7 pi over 6. So what happens is we start at the initial side, we rotate counterclockwise, so in the opposite or in the negative direction, we hit 180 and we keep going 30 degrees more until we get to negative 210 degrees. So this angle right here, we could call this a negative 210 or positive 150 degree angle. But because we're measuring the negative angle, it is negative 210. Negative angles rotate clockwise. All right, what is a coterminal angle? The name coterminal, co means partnered or with, right? Terminal is where the side of an angle ends. So coterminal angles are simply angles that have different measures, but they share the same terminal side. They end in the same spot. So if you took this 30-degree angle right here, this is 30 degrees or pi over 6 radians. There are infinitely many number of angle measurements that end at this terminal side. So let's look at a few. We took this angle, and from the 30-degree angle, how could we find another that ends here? Well, if we did another full rotation, if we did another full 360 degrees, because that's the full rotation, that's a full circle, we would end at the same spot. So if we did that, where would we be? Well, let's see. We're here at 30. If from 30 we went plus 360 degrees more, another full rotation, we'd be at 30 degrees plus 360 degrees, or 390 degrees. If we're thinking about this in terms of radians, nothing changes. We just add 2 pi instead of 360 because 2 pi is equal to 360. So if we started here at pi over 6 and we went a full 2 pi more, we would be at pi over 6 plus 2 pi, which is 12 pi over 6, so we'd be at 13 pi over 6. Therefore, coterminal with 30 degrees is 390 degrees. Coterminal with pi over 6 is 13 pi over 6. Okay, could we find a coterminal angle if we went in the opposite or the negative direction? So could we start at this 30 degrees or pi over 6 and travel clockwise a full rotation and get another coterminal angle? And absolutely we can. So this is what it looks like. If we start there at our initial terminal angle, and we travel in the negative direction, we go 30 minus 360 degrees, right? We started up here at 30 degrees. We did a full rotation in the negative direction. So minus 360 degrees puts us at negative 330 degrees. Again, if we call this pi over 6, we subtract 2 pi from it. We then get negative 11 pi over 6. So this shows us that 30 degrees, 390 degrees, and negative 330 degrees are all coterminal angles. And it makes sense. I just got 390 by adding a full rotation from 30 degrees. And I got negative 330 degrees by going a full rotation in the negative direction from 30 degrees. We also learned that pi over 6, 13 pi over 6, and negative 11 pi over 6 are all coterminal angles. They're just measured in radians. And it makes sense for the exact same way. So this shows us that any angles that differ by a multiple of 360 or a multiple of 2 pi are coterminal angles. They are going to end at the same terminal side. All right, let's practice calculating a few because this might be new for a lot of you. So if we started with a 115-degree angle, and I want to know, okay, I'm at 115 degrees. How am I going to find an angle that ends at that same terminal side? I'm just going to add a multiple of 360. I could add 360, but let's add 720. How did I get 720? 360 times 2 is 720. So I'm at 115 degrees, and I just went around the circle twice. 2 full rotations, puts me at 835 degrees. 835 degrees is coterminal with 115. Okay, now from 115, let's go backwards 360 degrees. We get to negative 245 degrees, also coterminal with 115 degrees. We have found a positive and a negative coterminal angle for 115. Okay, let's start from a negative angle, negative 30 degrees. Now, from negative 30 degrees, I just want to add 360 and see where I am. Because negative 30, it seems tricky, but really it's an angle we've seen before. Negative 30 plus 360 is 330 degrees. And let's look at a picture over here. So this right here is negative 30 degrees. This ray right here, this terminal side, is negative 30 degrees. Because we started at the initial side, we started at what we usually consider the x-axis, and we went in the negative direction 30 degrees. But we are really used to seeing this as a different angle, right? We could travel with this purple arrow going down negative 30 degrees, but we're used to seeing this as positive 330. This is the same angle as positive 330 in quadrant 3 that we're used to dealing with over and over again. All right, so we found a positive coterminal angle for negative 30. Let's find a negative coterminal angle. And let's find that by subtracting a multiple of 360. So let's do negative 30 minus 1080. How did I get 1080? Well, 360 times 3. So I started at negative 30, and I went in the negative direction once, twice, 3 times, and that is going to put me at negative 1,110 degrees. It will have the same terminal side. It will be sitting right there. Okay, one more. Negative 240 degrees. So negative 240 degrees, if I want to find a positive coterminal angle, let's add 360. So negative 40 plus 360 is a positive 120 degree angle. If I want to find a negative coterminal angle, let's do negative 240 minus 720. Remember, 720 is simply 360 times 2. And that puts me at negative 960. So to calculate coterminal angles, you're just going to add or subtract any multiple of 360 degrees. Since we don't think in radians, let's practice it with radians. So we're going to find a positive and negative coterminal for each of these angles. Here we have pi over 4, which you may already know is 45 degrees, but you don't have to for this. We're going to find a positive coterminal angle. So think about this. If I'm at pi over 4 radians, that's my measure, the angle measure I'm at, and I go a full rotation, I'm going to go a full 2 pi. So let's add 2 pi. Pi over 4 plus 2 pi. Now realize 2 pi does not have a common denominator with pi over 4 because it doesn't have a denominator. So we're going to say 2 times 4 is 8. So 2 pi is equal to 8 pi over 4. So let's rewrite this. Pi over 4 plus 8 pi over 4. That's 1 pi plus 8 pi, or 9 pi over 4. That's our positive coterminal angle. Now let's simply start at pi over 4 and go in the negative direction of full rotation. So let's subtract 2 pi. Pi over 4 minus 2 pi. Remember, 2 pi is 8 pi over 4, so let's rewrite it. Pi over 4 minus 8 pi over 4, that's 1 pi minus 8 pi, gives us negative 7 pi over 4. Great, let's do one more. 4 pi over 3. And again, I want to find a positive and a negative coterminal angle. This time, I'm not going to add 2 pi. I'm going to add 4 pi, because if I do 2 rotations, that's 2 pi times 2, or 4 pi. Again, 4 pi has no denominator, so 4 times 3 is 12, so I'm going to have 12 pi over 3. 4 pi over 3 plus 12 pi over 3 is 16 pi over 3. That's my positive coterminal angle. Now let's subtract 4 pi. So we're going to go in the negative direction, or in the clockwise direction, 2 full rotations. 4 pi over 3 minus 4 pi is the same as 4 pi over 3 minus 12 pi over 3. We get negative 8 pi over 3. So to calculate coterminal angles, if they're given in radians, you're simply going to add or subtract a multiple of 2 pi. And that does involve rewriting 2 pi or the multiple of 2 pi as a fraction with a denominator. That's not too bad. We did it. You saw. We survived. Okay, what's a reference angle? Reference angles are so important. We're going to learn how to calculate them. We're not really going to do much with them, but I'm telling you, for the rest of trig, reference angles are going to be your best friend. A reference angle is simply a positive acute version of any given angle. Okay, so here's what I mean. Right here we have an angle. This is a 135-degree angle. And when we are measuring angles, we're measuring the angle created from the x-axis. So a 135-degree angle creates the same angle with the x-axis as which angle? Well, as a 45-degree angle. If you looked at this, you go 135 this way, what do you have left to get to 180? You have 45 degrees left to get to 180. Therefore, a 135-degree angle and a 45-degree angle create a same angle, the same exact angle with the x-axis. Okay, that's all well and good, but why do we care? Because the trig functions for any angle are the same as their corresponding reference angle, not including the sine. You do have to pay attention to what quadrant you're in when you're finding trig functions. But if you're asked to find the trig functions for a 135-degree angle and you don't remember them, but you know your 45-degree angles, you're great because the trig values for 135 and 45 are the same, not including the sine. And we'll have a really cute way to remember your sines in the next lesson. Okay, so now that we know that, yes, reference angles are going to be important, how do we determine them? Okay, well, first your angle must be between 0 and 360. And actually, it has to be from 90 to 360 because 0 to 90 are already positive acute reference angles. So if the given angle that you're asked to find a reference for is not less than 360, you're going to have to find a coterminal angle it is. You see why we just learned coterminal angles? Okay, second, determine which quadrant the angle you're given lies in. This is going to be really, really important. This is where the terminal side lies. This quadrant is also going to determine the sign of the trig function later on. So the quadrant's really important. Okay, then you're going to use the rule associated with each quadrant. Okay, so whatever quadrant the angle theta is in has its own rule. All right, well, let's look at those rules. Here we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Think about this. We want to find coterminal. We want to find an angle that measures the same from the x-axis as it does in the first quadrant. All right, so if you have an angle in the first quadrant, you want to find its reference angle. What are you going to do? Nothing. These are your reference angles. All right, remember our 135-degree angle. That was the same as a 45-degree angle. So what's the rule for second quadrant? Second quadrant, you're going to take 180 and you're going to subtract the angle. Remember 135, we knew that there was 45 more to get to 180. So we did 180 minus 135 and we saw it was the same as a 45-degree angle. Okay, what about quadrant 3? Quadrant 3, so now you're talking about angles like 210. So you're going to take the angle, like 210, and subtract 180, and that's going to give you the measure from that terminal side to the x-axis. Okay, so if I want to know terminal side to the x-axis in quadrant 4, what do you think I'm going to do? What if I had 330 degrees right here? How much more to get to 360? Well, 30 degrees. How do I know that? 360 minus whatever angle you're given. So that's how we determine reference angles. You look at what quadrant you're in. If you're in the second quadrant, 180 minus the theta is going to give you that leftover, that angle with the x-axis. If you're in quadrant 3, you're going to do the angle minus 180. That's going to give you the little angle with the x-axis. Here, how much more to get to 360 if you're in quadrant 4? 360 minus the angle you're given. All right, let's do some. Okay, we are going to determine the reference angle for theta, an angle that is in standard position that measures 210 degrees. So this is a really long way your book is going to ask you, and it's just saying, what's the reference angle for 210? Why it tells you it's a reference, find the reference angle for the theta that's in standard position, I don't know. That's just how they word them. But you're going to find the reference angle for 210. Well, your first step is you need to know what the heck 210 looks like, so you have to sketch that angle. It measures 210. Get your axes. You're going to say, okay, we're going to do a rough sketch here. Here's 180. I need, 30 more to get to 210, so I'm going to draw that in right there. That's 210. Perfect. Now I'm going to look at what quadrant I'm in, and I'm going to apply the quadrant rule. I'm in quadrant 3, so I'm going to apply the quadrant 3 rule. Remember, quadrant 3 rule was the angle minus 180. So we have do nothing, 180 minus theta, theta minus 180, 360 minus theta. So I'm in quadrant 3. Angle theta, 210 minus 180. So if I apply that rule, 210 minus 180 is 30 degrees. Okay, so now I'm going to determine the reference angle for theta that measures negative 120 degrees. Okay, so negative 120 degrees, my first step is to determine a positive coterminal angle. I don't have a positive coterminal angle between 0 and 360, so I can't do anything yet. So how am I going to get a coterminal angle that's positive with 120 degrees? I'm going to add 360. Negative 120 plus 360 degrees is 240 degrees, right? What do I do next? Well, next I need to know where this angle is. So I've got to sketch it. If I sketch it, rough sketch again, it's going to be not too far from my last angle. Here we're in quadrant 1, so this is up to 90, this is to 180. This goes down to 270, so 270 is too far. So I'm going to say there we are at 240. Okay, so there's my 240 degree angle. I'm going to apply the quadrant rule. Again, it's in quadrant 3. So I'll do 240 minus 180, and I get 60. So my reference angle for negative 120 degrees. So if you're asked to find the trig functions for negative 120 degrees, you might not know them. You probably won't. But you'll know the trig functions for 60, and you'll just use the sign associated with quadrant 3, which we'll learn next lesson, and you'll find the trig values for 60 will apply. All right, that is it. That's coterminal and reference angles. Still have questions? Subscribe to our YouTube channel. Send those questions in, and we'll make you a custom video solution. Till next time, Math Hoppers, take it easy.